Welcome to the project demonstration of Pseudo DC link EV charger with high semiconductor device utilization factor. Means this is the factor we are going to use by making the high semiconductor device, and that will be controlled by our PIC microcontroller. So here the power flow is, so this section is considered as a EV electrical vehicle section, and this one is a DC to DC bidirectional converter. And next, so we are going to provide that to the grid section. This one is representing as a grid section, that is a AC grid and a DC grid. For the DC purpose, we are representing as a DC motor, and for AC purpose, AC load, we are using that. So the bidirectional means battery, means it is the grid section to the vehicle section, and again vehicle section to the grid section. So the bidirectional will be section achieved by our PIC microcontroller based on the switching of these MOSFETs inside this DC to DC converter, and for DC to AC converter we are using this HV circuit. So this extra section is for battery charging purpose, a safety mode. Just by connecting the 230 volts AC input to that, the light indication will show the status of battery charging. So it will be fully charged in a duration of 6 to 8 hours maximum. So after 8 hours, automatically the charging circuit will block the current flow from the charging circuits, and also if the battery is fully charged in between the time, then the current flow will be stopped from the battery to the charging circuit, so that we can protect the charging circuit, and also for overcharge from the overcharging also. So once the time completes, you can just switch off the power supply to the transformer. And then coming to the battery ratings, so this EV section, this battery consists of two 12 volt 1 amp batteries are in parallel. So battery pack 1 and battery pack 2. So each battery pack consists of 3 4 volt 1 amp batteries are connected in series. So we will get 12 volt 1 amp from the battery pack 1, 12 volt 1 amp from the battery pack 2. So parallel connected, so we will get the 12 volt 2 amp. So that is the input to this DC to DC converter, so bidirectional converter here. So based on the signal given to this MOSFETs from the microcontroller from the B0, B1, B2, B3 pins, and there we are going to provide the constant current, because as we know that if you want to run the inverter in the DC grid, then we need to provide the constant voltage and constant current. So when we are running these two loads in the grid section, the 230 volts and 12 volts, then there will be a chance of power fluctuations. In order to maintain the constant current and constant voltage, we are going to making use of this DC to DC converter, so which will take input from the both end. So when we are utilizing that to the AC, then this will act as a 12 volts DC to 12 volts DC output to constant with 2 amps. So in reverse also, when we are putting 12 volts 1 amp here, so which will make it as 12 volt 2 amp to make it sufficient to charge a battery. So that will be achieved by a microcontroller. And here if you want to convert DC to AC, then we need to convert the 12 volts DC to 12 volts AC initially. For that purpose, our microcontroller will convert the 5 volts DC to 5 volts AC signal, that is from this cable, 3 pins. So one is the ground, 2 is the inputs to this MOSFET section. So means the 5 volts DC to 5 volts AC from here, and 5 volts AC to 12 volts 2 amps AC after this HV circuits with the help of this MOSFETs, means that to 50 hertz of frequency, because we need to get the 230 volts 50 hertz frequency. So for the purpose, 5 volts DC to 5 volts AC, 5 volts AC to 12 volts AC of 2 amps, and that will be step up to the 230 volts AC with the help of this step up transformer. So it will take 12 volts AC input and provide us a 230 volts AC output. Again parallelly same, we are providing that to our DC grid section for utilization for the motor application. So let us see the application for the inverter also. So when we on that, this LED will be on and off 2 times, and after that, so we can see the low voltage is generated as we are providing the practical application for DC to DC converter. And also the battery got bit discharged, so it will be fully charged in a duration of 8 hours. After that, we will get the bit more brightness to this bulb circuitry. So as the flow is, we explained, so EV to the DC to DC converter, and next DC to DC converter to the DC to AC here, and DC to DC directly to the DC load here, and parallelly direct output was to the battery.